Alright, so we're going to get ready to solve exponential equations, and what I'd like to do before we get into the meat of those ones is I want to revisit the idea of the change of base formula. Alright, and so recall for our change of base formula, what we basically, what we have done before is when we were solving an exponential equation, the trick was to get the bases to be the same. And then once I had the bases the same, we were able to basically just compare exponents. But in this case, we can't do that, right? Because 17 doesn't turn into a nice base 4, right? There is actually a value you can raise 4 to get 17. It's just not nice. It's not like solving something like 4x equals 64, right? Because here we can rewrite 64 as 4 cubed, and then we get x equals 3, right? So that was back in 6.3. The exponential equations were nice enough where we can at least get the same base and then compare exponents. Here in 6.6, things are a little bit more challenging because we can't do that, right? But what we have is a logarithm, and initially, because we're base 4, if I just do a conversion, right, what we get is, if we convert this, we're saying that log base 4 of 17 is x, right? Or put another way, the solution to this equation, right, is log base 4 of 17. So that is a solution that we get by just converting it from its exponential form to its logarithmic form. But our problem here is base 4 is not on my calculator, right? We've learned we can definitely use the change of base formula to get there. And the idea is I can change this to any base that I wanted to. Just as we'll just take the log of the new base of what I was taking the logarithm of and divide it by the log of the new base of the old base. So we just used it in the past, but I'm actually going to prove it now. Because if we apply a log to this, right, so log base 10, look what happens. So if I apply log, what I get is log of 4x on this side and log of 17 on that side. Now what happens here is we've got our exponential rule of logarithm, so that x we can move out front. Okay? And then to solve for x, we have to recognize the fact that log base 4 is a number, right? So what I can do is get x by itself by dividing both sides by log base 4. So over here it cancels out, and what we get is log of 17 and log of 4. Right? And bigger picture, that means that this guy and this guy are the same. And it's basically our change of base formula with base 10. We went from base 4 to base 10. Of course, it could apply to any base. So what happens if I take that same equation and I now apply the natural log? Right? Well, the same thing's going to happen. I'm going to get the natural log of 4x, 4 to the x power, equals the natural log of 17. Again, our exponential power rule works here, so we have x times the natural log of 4. And so to get this x by itself, I'll divide by the natural log of 4. And so we get x equals the natural log of 17, the natural log of 4, which is basically what our change of bases formula is telling us to do. So if I have base 4, I can change it to base e. Just make sure you take the natural log of what we were taking the logarithm of, and then the new log of the old log. So we can keep going on and on. So how about I just come over here? So what if I apply any log, right? Log base b. So if I apply it to that, we get log base b of 4 to the x equals log base b of 17. My exponential power rule starts. So we get that. Oops, that's a b. And then to get x by itself, I'll divide by log base b. Okay, and so x is any logarithm base b of 17 divided by any log base b of 4. All right, and so again, you can replace the 17 and the 4 with m and a, and you basically have your change of base formula. So there's your proof of it and why it actually works. For us, what it does, let's come back over here. Let me grab my calculator. Right? So what is the power that I can raise 4 to get 17. Well, according to our change of base formula, it's log 17 divided by the log of 4. And it looks like our x value is 2.043731421. Right? You can check it, right? Because if I take 4 and basically raise it 4 and raise it to that power, I'll just put the answer up there, what you get is 17. All right, so we've got it. All right, so there's the value that I can raise 4 to get 17, and I got there multiple different ways. I either did a straight out conversion and then used the change of base, or I applied any logarithm that I want, log base 10, the natural log base b, apply whatever one you want, apply your rules, and you can solve for x that way. So a couple of different ways to attack that. All right, so there's your change of base formula officially. Now we are truly ready to solve much harder exponential equations, not the easy ones, the harder ones. So we'll do that in a video coming soon.